Hello students, today I'll be discussing a question that is a numerical of a charged particle when it is placed in a magnetic field and what will be the radius experienced by the particle. Okay, so what will be the radius of the particle? So the question goes like this, as you can see on the screen. The question is a beam of alpha particles and of protons of the same velocity v enters a uniform magnetic field at right angles to the field lines. The particles describe circular path. What is the ratio of the radii of the two circles? That means यहाँ पे जो क्वेश्चन पे देख सकते हो कि क्वेश्चन पे दिया हुआ है कि we have a beam of alpha particle and a beam of proton. ठीक है, alpha particles है और proton है. We have a beam of alpha particles and we have proton. Okay, we have proton. Moving with the same velocity, both are having the same velocity. Both are having the same velocity v. Enters a uniform magnetic field at right angles to the field lines. So we have suppose we have a magnetic field, uniform magnetic field, equally spaced parallel lines. So this is your uniform magnetic field. So this alpha particle and a proton both are entering at the right angles to the magnetic field. That means this I can consider as the alpha particle and the proton. Both are entering to the magnetic field at an angle of 90 degree. Then it is given the particle describes a circular path. What is the ratio of the radii of the two circles? ये तो हम लोग को पता है कि जब भी पार्टिकल को हम लोग परपेंडिकुलरली टू द मैग्नेटिक फील्ड प्लेस करते हैं तो वहाँ पे जो फोर्स एक्सपीरियंस होता है तो वो ऑब्जेक्ट या पार्टिकल वहाँ पे सर्कुलर मोशन पे मूव करता है. जो जैसे ये अल्फा पार्टिकल हो या प्रोटॉन हो, दोनों जब मैग्नेटिक फील्ड में 90 डिग्री में प्लेस किया जाएगा तो वो पार्टिकल क्या होगा, वो पार्टिकल मूव करेगा एट एन एंगल ऑफ 90 डिग्री. Okay, so it will be moving in a circular path. So if I consider a circular path, we know that if it is exhibiting a circular path, that means it is experiencing a centripetal force. And who is exhibiting the centripetal force? Here the centripetal force is provided by the magnetic force. And we have already derived a formula for the radius of the particle. So if I consider radius of, first if I consider here magnetic force is given by QVB is equals to mv square by r. Okay, this is the magnetic force is equals to the centripetal force. So from here if I calculate the formula of radius, so 1v and 1v get cancelled, so it will be mv by qb. This I can mark as equation number 1. This is a general equation for the radius. This we have already derived. So if I use for the alpha particle, so the radius of alpha particle, so it will be mass of alpha particle, then it is given a velocity of the alpha particle, but since क्योंकि alpha particle और proton का velocity same है तो v ही हम लोग use करेंगे, divided by q alpha, that is a charge of alpha particle into its magnetic field. Okay, m alpha q alpha v by b. Now after this, this is for alpha particle. Okay, so this is for the alpha particle. Same way if I use it for the proton, for proton, radius of proton, it will be equals to mass of proton into velocity divided by charge of proton into its magnetic field. So if I mark this as equation number 2 and this is equation number 3, so it is given in the question that we have to find out the ratio of this alpha particle and the proton radius. So radius of alpha particle by radius of the proton we can write as m alpha v by q alpha b into qpb, that is a charge of proton into magnetic field divided by mass of proton into its velocity. So here this magnetic field and this magnetic field will get cancelled, velocity and velocity will get cancelled, so the remaining part it will be mass of alpha particle by mass of proton into charge of proton by charge of alpha particle. Okay, so here we have got mass of alpha particle by mass of proton, charge of proton by charge of alpha particle. Now let us see after doing this what will I get. After doing this part, the charge of proton and a charge of alpha particle. The alpha particle is considered as a twice of electron energy. That means here I can consider as a twice of proton, because the proton I will be considering as a E, here I will be considering as 2E. That means this 2, if I calculate the ratio, what will I get? R alpha by Rp, it will be M alpha by Mp, that is the mass of proton. It will be equal to 1 by 2. Okay, so it will be 1 by 2 ratio. Because of this Qp by Q alpha, because Q alpha is considered as twice of electron. Then after this, if I consider here the mass of alpha particle and the mass of the proton, here it will be, this is 4 into 1 by 2. So 2 it will be cancelled. So it will be 2 R alpha by Rp. So R alpha will be equal to twice of radius of proton, or you can calculate this as a ratio as a 2:1, because in the question it is given we have to find out the ratio of these two. Okay, so we have got the answer as 2:1. So this is how we have to do the numerical related to this. This is a question based on CBSE. Okay, CBSE boards, that's why I have done it. So in the next class we'll be discussing the next chapter. So in the next class we'll be discussing about the magnetism and the magnetic materials. I think most of the parts of this chapter that was deleted previously, this year also it will be deleted because of this the pandemic situation. So we'll be discussing some topics related with the magnetism and the magnetic materials, like we have the ferromagnetic material, diamagnetic material, paramagnetic material. These are some types of magnetic materials where it shows some properties related with the magnetic field. So we'll be discussing